This is the first lecture on Chapter 10, Correlation and Regression. So what we're going to do is we're going to start out with the vocabulary, and we're going to start out with the scatter plot. Scatter plot is a graph of order pairs x, comma, y. So the correlation and regression in Chapter 10 that we're going to study is a representation of a relationship between two variables. Generally speaking, x is called independent variable, y is going to be called dependent variable, and what we're looking for is there a relationship, let's say if one increases, the other one increases, or if one decreases, the other one increases. The correlation never means causation. It doesn't mean that one causes the other one to increase or decrease. What it does mean is that there's a relationship between the two variables. A scatter plot is a graph that looks like a bunch of points on an XY chart that represents that relationship. So if you see a pattern, that means that you might have some regression analysis, and if it looks like a cloud of points, that means that there is none. The statistical test that we're going to be doing this chapter will prove or disprove the existence of correlation. So what we're going to be doing is we're going to be doing the test for significance of the correlation coefficient. The correlation coefficient is the correlation computed by all possible pairs of data values taken from the population. So a correlation coefficient is something that we're going to be able to compute the population one, and it's a relationship between x and y, meaning how strong the relationship between x and y is. So let me kind of introduce a symbol here. The population correlation coefficient is labeled with the letter rho. Now this is a Greek letter, just like all of the other correlation, just like all of the other parameters. I did go under Insert, and under my equation editor, I'm going to select the Greek letter, and I don't know if you can see the drop-down menu, but the Greek letter is supposed to look like this. I'm going to unbold it. It looks like a smooth version of a letter P. So its name is rho. It's not a P, it's a rho. And this is how we're going to label a population correlation coefficient. A sample correlation will be denoted with the letter R. A linear correlation coefficient, which is the same thing as a sample correlation coefficient, computed from the sample of data measured the strength. So I didn't actually need this. Sorry, I panicked. So the linear correlation coefficient computed from a sample data of points measures the strength and the direction of a linear relationship between two quantitative variables. So the letter that we're going to be using here is the letter R. And if anything, rho is going to be your hypothesized correlation, and R is the statistics. It is the sample correlation that you see from a given set of points. The line that is a line of best fit is a potential linear relationship. So we are going to study different, so you can study different kinds of correlation relationships, but the one that we're studying in this class is called a linear correlation, meaning I'm trying to see if there's a linear relationship between the x and the y. That means that through any cloud of points, hopefully that looks like it has a positive or a negative trend, we can draw a line. The line is called the line of best fit. Another name for it is the least square regression line. It is the type of regression that we're studying in this class. That's the formulas that are programmed under your TI-83, TI-84 under the linear regression, and it looks like a form of A plus BX. A residuals is the difference between the actual value and the predicted value. So let's say you have a point 2 comma 5, and then you plug in your 2 into your line and it says no, it's a 6. Well, the difference between 5 and 6 is the negative 1, meaning well, you were off by 1 in the negative direction. The coefficient of determination, the coefficient of non-determination, and the standard error of the estimate is something we're going to discuss in 10.3 or 10-3 within the lectures. In the next videos, I will start with the lectures on 10-1.